I will demonstrate a basic Level 1 hardware application for Oleumtech hardware, which includes a Modbus master. We will use a software to emulate, a Modbus slave DH2 connected with a black phantom antenna, an N node, an RTD transmitter connected with a platinum 100 ohm RTD temperature sensor. We use our configuration cable for DH2. We use our configuration pigtail for transmitter. We'll use our USB to serial converter. Now we will move on to the software build. First, to configure any Oleumtech hardware, you must have Breeze configuration software. If you do not have it, please go to www.oleumtech.com. Use these instructions to download the software. Once you have the software, you open it, go to Edit, Options. Here you will set up your PC port parameters. Identify the port you are using. Leave at 57600, none, and 1. For these are the parameters of Breeze. Then OK. Then move to a blank project. Name your project. Today I will name it Line Temperature. The 2.4 GHz checkbox is for overseas hardware only. The channel availability is up to 9. The group availability is up to 999. You can set this as you wish, but please dial away from each other if sites are closer than 2,500 feet. The bitrate defaults to 9600, but is selectable to 115-200 if needed. The Enhanced Site Security checkbox should remain checked, and this will preserve the integrity of your data and not allow sites to crosstalk. Then click OK. Double-click on the name, right-click, and insert your first piece of hardware, a YODH2. Double-click on DH2, right-click, and rename. Today I will name it DH2/RTU to signify that I am interfacing to an RTU. Then right-click on DH2, go to Properties, Edit. Here you will set up all the parameters of the DH2, starting with Radio tab. Because you have a power supply available here, you are allowed to set up to 1000 milliwatts. 1 or 10 is sufficient for testing. Leave retries at 16. Move to Configuration tab. Configuration tab signifies the RJ jack in the back of the DH2, where Breeze comes in with its configuration. It should remain at default 57.6, none, and 1. Move to the RTU tab. The RTU tab signifies the Phoenix connector in the front of the DH2 and should be set up accordingly. If you are using 485, you would check this box. You would ID your slave accordingly. If extended register addressing was needed, you would use this checkbox. If you needed to split 32-bit values in your RTU, you would use this checkbox. You would set your baud rate accordingly to what your RTU or PLC is. Today we will use 9600, none, and 1. We are using 232, so I am not checking the RS-45 box. Then click OK. Now double-click on DH2, right-click, and insert an RTD transmitter. Double-click on transmitter, right-click, and rename. Line Temp. Right-click, go to Properties, Edit. Here you will set up all the parameters of the transmitter, starting with Radio tab. Because this is a Class 1 Div 1 self-contained battery, 1 or 10 milliwatts is all that is allowed. We suggest 10 if your distance is greater than 100 feet. The node timeout is an RF flag that will signify to the DH2 if data is not received in this time frame. This should be set at 3 times or 4 times greater the reporting interval shown on the next screen. Leave retries at 16. Go to RTD. Here is the reporting interval that you will ask the sensor to report to the DH2. We will set this for 1 minute today. Return to the radio tab and put our node timeout at 4 times greater than our reporting interval, and then move to Exports tab. Here we can set what registers we want to be exported by moving them from side to side with the arrows. And today we want to utilize the 3 different of Fahrenheit, battery voltage, and RF timeout. Push Set Template, so the next time you pull up an RTD transmitter, it will be set like in kind, and then OK. Now that parameters have been set in the file, we will move to build the Modbus list. Double-click on DH2, click on Imports in your center window. Notice the 3 imports that are being exported from the transmitter into the DH2. We will click and shift-click, right-click, and go to Modbus, Paste to Float Table. Then go to the Modbus tab and confirm that they did paste to the float table. Now your Breeze file configuration build is complete, but must first be saved before it can be updated to hardware. Click the Save button. In the Save window, name the first half of your file name. Level 1 RTD. Now your file is saved and ready to be loaded to hardware. The connections for the DH2 are a Phoenix connector in the front for 232 or 485 communication wiring to interface to your Modbus master. You also have jumpers beside this connector that must be installed if using RS-485. You also have power and ground connection. On the back of the DH2, you have your configuration port, an RJ jack, which is used to download your configuration from Breeze. On this side of the DH2, you have an MMCX connector, which is used to connect your antenna. And that is all the connections of the DH2. In order to download the configuration file to the hardware, you must first connect your configuration cable from the PC to the RJ jack port in the back of the DH2. Then double-click DH2, right-click, and click Update Device. If the Site Security Mismatch window comes up and asks if you want to reprogram the security key on the field device, yes will change the key and push the file. No will not change the key but will still push the file. Today we have a brand new file, so yes, we want to push the new security key. Notice that in the output window you should see DH2 RTU configuration download OK. Transmitter connections include a 3-pin flat for battery connection, a 4-pin flat for Breeze configuration connection, and the reset switch is located right beside both connections. Now you can remove your configuration cable from the DH2. Install your configuration pigtail for the transmitter. Then plug the 4-pin flat into the transmitter. Then double-click on line temp in your file. Then right-click on the device. Go to Update Device. Yes, accept the new file. Confirm with line temp configuration download OK. While still connected to the RTD transmitter, double-click, right-click, click Connect. Click on the RTD tab. Click on the Read button. Notice the Celsius value, the Fahrenheit value, and the transmitter's voltage. Also notice the RF OK in the upper blue bar. This signifies that the DH2 acknowledged the data correctly. And click OK and OK. Now we can remove our configuration cable from the RTD transmitter and put it back into the configuration port of the DH2. Put your output window in the Debug tab, and here you can monitor all transmissions that come in from the end node RTD transmitter. See our RX packet Group 1 Node 1 length 14 with an RSSI value of 43, and that is happening every 1 minute, exactly as we configured it in the transmitter. Now that we know that our Modbus data is being reported to the DH2 on 1 minute intervals, we can move forward to set up our Modbus master. Today we will be using simply Modbus. I set up my Modbus master across COM1 9600 8 none and 1, slave ID of 1, my first register of 7001 for 3 registers. I want to ask for exactly the way it's built in the Modbus list, being temperature Fahrenheit, battery voltage, and RF timeout, exactly as I have this laid out. And then I will send this Modbus request. Notice when I do, in the debug window, the response is returned with a Fahrenheit temperature, a battery voltage, and no RF timeout. Notice that my Modbus master is also populated with the same information. We have now completed the Level 1 RTD line temperature breeze configuration file build. We updated both pieces of hardware with said file, and then we confirmed that they were delivering data back through debug and that the Modbus request block was being responded to in a correct manner, that all data points were delivered accurately to the Modbus master. This can be easily accomplished with multiple end nodes.